Hello everyone, this is Sai Sri and welcome back to my channel. In this video, let us see how to simulate vein bridge oscillator using multisim software. Before jumping into the video, make sure that your video resolution is about 1080 pixels or 720 pixels so that you can see the every name in the component in the circuit very clearly. If not, it will be blurred so that you can't understand the circuit diagram properly and the values of the resistors and all. So before that, make your video to the resolution of 1080 pixels or 720 pixels. In this video, we are going to cover how to design a vein bridge oscillator and how to see the output in your oscilloscope, and then I will show you a document in which you can have the aim, apparatus and the theory part of the vein bridge oscillator, the circuit diagram and what are the values we have to take and how to calculate the theoretical frequency of the oscillations and how to take the practical frequency of oscillations. So all those parts I'm going to cover here. So before that, this video took me a lot of time in order to record, edit and give a voiceover. So if the video is informative and useful to you, please do subscribe to our channel and share it to your friends. Firstly, we will place all the components required to this by clicking on place and then components, and then we have to search for the components in the all groups. So firstly, for the vein bridge oscillator, we require two BC107 transistors, so I have placed them. Now we require some resistors and capacitors, so select basic and then you can find the resistors and the capacitors. So whatever the value you want in that circuit, just type that, then you can get the capacitor or the resistor of that value. Simply click on OK, drag it and give a right click on the mouse so that the component will be placed on the breadboard. So in the same manner, place all the capacitors and the resistors as shown in the video. I have made a playlist of multisim series in which you can find other experiments also. I will also drop the links of other experiments in the comment box and in the description box. Please do check out them. Now it's time to connect the components. Make sure that don't skip any part of this video while connecting. If not, you are not going to get the output. So please do it carefully while connecting the components and their wires, especially at the nodes. check the nodes where the resistors or the capacitors are connected. If any resistor or the capacitor value is wrong, you are not going to get the output. So here you can see, here we have placed 680 kilo ohms, but we have to place 680 ohms. So we can change the value by clicking that resistor, and then a window will be open. So here you can change the value of the resistor. So this is our final circuit. Please make sure that your circuit is matched with the circuit shown in the video. If not, please change it. So this is our final circuit. Just click on run button or the triangle symbol. So here you can get the sine wave. So wein bridge oscillator is going to produce a sine wave. So when we are going to click on the run button, we are not getting the sine wave immediately. So after some time we are getting the sine wave. So it takes some time in order to get that sine wave. So that we are going to take it as a practical value of the frequencies. So now up to it is the simulation part of the wein bridge oscillator. Now let us see the document of the wein bridge oscillator, the aim apparatus, the circuit diagram and the output. So instead of using the DC power 12 volts, we can also use VCC 12 volts. Both are same. So this is the procedure which we have followed in connecting the Wien bridge oscillator and getting the output. So to note the frequency of oscillations or the practical frequency, so as I have said before, so when we are clicking on the oscilloscope, we are not getting the output immediately. So after some seconds of time, we are getting the output. So that time period we are taking as a practical time period. So the practical frequency is nothing but the inverse of the time period. So inverse of the time period is taken as the practical frequency. So here when we click on the run button, so we haven't got the output immediately. So after some time, it is about 49 point something seconds. So it is the practical time period. So the practical frequency is inverse 1 by t. F is equal to 1 by t. So practical frequency is 1 by 49 seconds, milliseconds. So that frequency we have mentioned here.